My STEM pathways experience is most likely not what everyone else went through. My project began nearly 2 years ago and is carried on consistently to today, meaning I did a lot of the early work, such as brainstorming or defining criteria and constraints many years ago. But I still feel like I need to account the whole process, even everything done outside of this year. It started 2 years ago when Mr. McCrory in the STEM engineering class gave us the problem of attempting to disperse seed balls. And I expect you to hear a lot about seed balls recently, but at that time we were the first group of people to work with them. We were very new to them. He also told us what we were going to solve with them. The problem at that moment was defined as deforestation in northern Kenya, and that has stayed the same throughout the whole process. With criteria constraints, there were some that Mr. McCrory gave us, which were it needed to use seed balls and it needed to move around by Camel. The rest were made up by us students to research any conditions the design will be put under. They can be seen on the screen now.
We then moved to brainstorming ideas, which meant thinking of possible solutions and find the ones that were the best. I was in a group, and as a group we decided that by using an electronic design would mean we would have the most control of where it drops. The photo on the screen now is the original brainstorming we did as a group.
From there we went to build a design. This was a lengthy process to do the program we needed to do to get the electronics working, along with finding a way to store the seeds. But we did eventually finish building the design, and that process is seen here. For me, the testing and refining process has been repeated 3 times. So here's a rough timeline of how it has been improved. After building the design, a camel was brought to ISK, which we strapped our designs onto, and walked it around to see if they worked. This gave me some feedback on what needed improvement, which was the consistency of electronics, so I could control the amount of seeds that dropped and the distance between them. You can spot my design in the clips by the one with the trash bags around. Then Mr. McCrory and Mr. Suter tasked me with improving my design over the summer to have it prepared for the SOI Trip. Over the summer, I worked on 3D printing many of the components to make the design more suitable for the conditions in northern Kenya. I didn't collect much evidence of the improvement because it was summer break, but here's my design running after I made the changes. Then the SOI Trip came along, which was a very important testing ground for the design, because putting the design under the conditions would be under if it was used in northern Kenya. During the trip, something unexpected happened, which was that my design broke and the electronic piece fell off. But by coincidence, it kept on releasing seed balls at a good pace because of the shaking of the camel. This was huge for me because I made a discovery into how I could make the design mechanical. The next semester, I changed my approach completely and made the design mechanical. I refined my design totally, and at the end of the semester, another camel showed up, which let me know if my design was up to par. The camel showed me that it definitely was. The design had become very consistent and was dropping a very good amount of seed balls every few meters. It was a huge success. The Swedish newspaper showed up to interview me and a few of the students on the project to explain what we were doing. I can only show you the title slide of the Swedish newspaper because they wanted me to pay to see the rest of the article, which I'm not willing to do. At this point I was done. It was time to share my solution. It was this year. I built my final product not using anything that was from the trash. All the parts need to be able to be mass produced. I created a manufacturing method along with the material for every single component, along with making designs for every single component. I don't have a photo of the final product because of COVID, but I do have a video showing off what my design looks like. If I reflect on the whole process, I had many successes, but there are also some things that I felt I could do better. My greatest success was definitely getting through the whole process of having an initial problem and moving on to having this final design with sketches and everything. I'm very proud of that. One of the highlights is definitely the media attention this project got. I think that's just very cool. But across the process, I also felt like I could have collected more evidence and data. I do have some of that, but I feel like having more of it will really show that my product is worth looking into and that it does work. Across that process, I learned that it can be difficult for me to stay interested in things for an extended amount of time. I would always get caught up in another project and let this slide into the background. That other project could have been for handout or another club or just working on something for school. But I also learned when I got into this project again, I got really into it. I would make huge amounts of progress in a very short amount of time. But I would always come back to this project, and at some point, it always seemed interesting. So overall, I've learned that I'm a person who doesn't stay focused on things for an extended period of time, but I won't ever give up on something till it's done.